Hello everyone. The title of this video is Solve Applications Modeled by Quadratic Equations. Each exercise I'm going to do in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.5 titled Solve Applications of Quadratic Equations, and I'm working under the heading Solve Applications Modeled by Quadratic Equations. I'm only going to be working on the even numbered exercises, so starting with 196, then going to 198, 200, 202, etc., all the way until exercise 226. Alright, so this will be a bit of a long one. And these exercises don't have solutions posted in the text, whereas the odd numbered exercises, 195, 197, and so on, you see have a link, a highlight that you click on, and you'll be taken to the solutions. Right? So I'm just doing the even numbered ones. Alright, also, I will have timestamps for when each exercise starts in the video in the description below. So if you see this in the description below, you'll see example 1. That timestamp will be for when I start 196. Example 2 for 198, example 3 for 200, and so on. So if you'd like to see a particular question worked out, just count down how many examples that would be, and then click on that timestamp in the description. All right, and one final request I have is that when I start a new question, pause the video and try to work on that yourself first before watching me do it and then comparing. Because if you're watching me do these things without practicing yourself, chances are you're not learning all that much. Alright, so the first exercise I'm going to do is 196. Now all we're asked to do is solve using any method. So 196 reads, the product of two consecutive even numbers is 360. Find the numbers. Okay. So I'm going to pull up where you can see the exercise still, right? Exercise 196 is still on the screen here. And I got a piece of paper here on the right corner, and after I write out the information I want, I'll make the paper bigger so we can, hopefully you can read my writing a little better. Alright, so number 1, exercise 196. Alright, now you could play around with it. It says the product of two consecutive even numbers is 360. Now you can play around with it, factor 360, and maybe eventually you'd get down to, oh yeah, it's 18 times 20. Right, two consecutive even numbers. But first I want to talk about, consecutive even numbers. So let me just make this bigger actually. When they say consecutive even numbers, remember, even numbers are just the integers that are multiples of 2. So, negative 6, negative 4 is the next consecutive one. Consecutive just means the next one, right? One right after the other. Negative 2, 0, 2, 4, 6, 8, and so on, right? So, negative 6 and negative 4 are consecutive. Negative 4 and negative 2 are consecutive. Right, but negative 6 and negative 2 are not consecutive. Right? It's just one right after the next. Notice that every time I go from one even integer to the next even integer, it's just adding 2. right? So from -4 to -2 is +2, +2, and so on, right? I just keep adding 2 to get to the next one. All right, now they say that, the product of two consecutive even integers or even numbers, right, is 360, right? And we're asked to find those numbers. Well, you work on these just like you would work on any word problem. You read through the problem, which we've done. Hopefully you understand what's being asked for. Then you identify your unknowns, right? Your variables, your variable expressions. So what are they asking me for? They're asking me to find these two numbers. So I'll say the first even number is unknown. All right, and I'm going to call this just n for number. Right? That's unknown. And the other unknown is the next one. All right, the next even number. The next consecutive one, which you could call something else if you wanted to. I could call it p or something, or whatever you want, x. But we already know a relationship between these. And the fewer variables you assign, the better. So if one of these is n, remember the next consecutive even integer would be n plus 2. I hope that makes sense. So I read through the problem, and then I assign, variable expressions to certain unknown quantities, things that they're wanting me to find. And then I take these expressions and read back through the problem and try to form, some sort of equation or inequality or system of equations or whatever to help me solve the problem. Now, in every single one of these exercises in this video, the equation we're going to solve, the equation we're going to set up, the model, is going to be a quadratic model. So watch, right? So look, I got the sentence right here. The product of these two numbers, and the two consecutive even numbers are n and n plus 2. Product means I'm multiplying them. So we have n times n plus 2, and then is, right, the product of two consecutive even numbers, n times n plus 2, is equals 360. All right, and then I'm going to solve this for n. Right. Solve this for n. Okay, so let's get this in a certain form. Distribute the n here. We have n squared plus 2n. And then equals 360. Now you can solve this in several ways. And we could subtract 360 and then use the quadratic formula. Or I can complete the square. I can solve this by completing the square. I would have to just add 1 to both sides. Alright, and then this left side here, n squared plus 2n plus 1 is the quantity n plus 1 squared equals, and then 361. And I'll tell you right now, 361 is 19 squared. 19 times 19 is 361. So by the square root property, n plus 1 is either 19 or n plus 1 is negative 19. And I get some solutions here. Here n equals 18. Here n equals negative 20. Both of these lead me to an answer. So here are the answers to their question, when they say find these numbers. One answer, when n equals 18, that's the first one, n. The next consecutive even number would be n plus 2, right? N plus 2 in this case would be 18 plus 2, that'd be 20. So 18 and 20 is one answer, right? There's two consecutive even numbers, 18 then 20, that multiply to be 360. But that's not all. The second answer I'm getting from this is when n equals negative 20. Right? When n equals negative 20, that's the first even number. Then the next consecutive even number, n plus 2, negative 20 plus 2 would be negative 18. So negative 20 and negative 18 is another answer to this question. Right? They're consecutive even numbers, and they have a product of positive 360, right? Negative 20 times negative 18 is positive 360. And there we go, right? And I double check those, right? Just make sure it makes sense with the problem. I'll highlight this with a different color here. That's an answer, 18 and 20. This is also an answer. These are both equally valid answers to their question. And you should be putting all valid answers. Great. All right, next question. Next question is exercise 198. Okay, here it says the product is very similar, but instead of two consecutive even numbers, it's two consecutive odd numbers. But the relationship between consecutive even numbers and consecutive odd numbers are similar. All right, if you go from one even number to the next one, you're adding 2. Same thing for consecutive odd numbers. You go from one odd number to the next odd number, you're just adding 2. All right, so the product of two consecutive odd numbers is 1023. Right, and we're asked to find these numbers. Okay, so again, I'll put this up with a piece of paper. All right, it says number 2 here. This time, hopefully you can read my writing. Right, when they talk about consecutive odd numbers, I'll just put the numbers like that. They mean the following. The odd numbers are these. Negative 5. Basically, any number that's one more than a multiple of 2. Negative 3, negative 1, 1, 3, 5, 7, 9, and so on. Right? These are all odd numbers, and consecutive odd numbers are just one right after the other. Right? So from negative 5, the next consecutive odd number would be negative 3. And notice that you're just adding 2. And then from negative 3 to negative 1, you're adding 2. From negative 1 to positive 1, you're adding 2. It's the same every time. Just like for consecutive even numbers. Alright, so I read through the problem. Now I want to identify the unknowns. So I'm going to let that first odd number that we're trying to find, I'm going to represent that with, n again. Why not? Right. So the first odd number I'll call n. And then the next odd number, right? We're looking for two consecutive odd numbers. Well, again, you can call it something else, but if I know the first odd number is n, the next odd number would be n plus 2. Right? You get from one odd number to the next by just simply adding 2. Alright, now comes the equation. Right, back up, read 198 again. Right, the product of these numbers is 1023. So n times n plus 2, right, here's the product of these two numbers, is, right, equals 1023. All right. And now that I got the equation written out, let's go and make this bigger. All right. I'm going to solve this. All right, so I'll distribute the n. This is going to be very similar to my first question. We have n squared plus 2n. And then I'm going to leave some space because I want to complete, I'll complete the square again here. This is 1023 on the other side. I would have to add 1, right, to both sides to complete the square. Then on the left side here we got n the quantity n plus 1 squared equals 1024, which is 32 squared. Right? I know that 1024 is 2 to the 10th power, which would be 2 to the 5th power squared, 32 squared. So n plus 1 is either 32 or n plus 1, could be negative 32 as well. And subtracting 1, we get n equals 31, or n equals, negative 33. So once again, there are two possible answers here. There are two totally valid answers. When n is 31, we got 31, and then the next consecutive odd integer would be n plus 1 would be 33. Right. And check it, 31 and 33, they're consecutive odd integers, odd numbers. And their product, right, if you take 31 times 33, that is indeed 1023. Right. Right. And I can pull up a calculator if you want to really check it, just totally verify it, or do it by hand. All right, but 31 times 33, 1023. Fantastic. And they are consecutive odd numbers. All right, so that's one answer. All right, but that's when n was 31. The other answer comes when n equals negative 33. Right? How about also negative 33, and the next consecutive odd would be negative 31. And those are consecutive odd numbers whose product, when you multiply them, would give me positive 1023. So both are good, right? You should be accepting both, writing both. All right, wonderful. Next question. All right, so the next question, exercise 200, reads, now it's pretty much the same as exercise 196, but with a different number here. The product of two consecutive even numbers is 528. All right, so again, I'll pull this up. We have a piece of paper. We got number 3, exercise 200. So again, the first even number, right, that first even number I'm looking for, I'm going to call n one more time. Right, why not? You can call it x or y or whatever you want. And then the next even number would be, since they said they're consecutive even, the first even's n, the next even would again be n plus 2. And it's saying that their product, right, n times n plus 2, their product needs to be 528. 528. All right, let me make that a little bigger again. And we're solving this equation. I'm going to solve it the exact same way I've been solving the other ones, right? And again, you can do other things. You can use a quadratic formula or complete the square, or try factoring. But however you want to solve a quadratic, you should know how to solve quadratic equations by now. All right. And then, yeah, I'd be adding 1 to both sides to complete the square on n squared plus 2n. So again, this left side is n plus 1, that quantity squared, equals, and then 500, oh, that's 528, sorry, 528, but then plus 1 would be 529. Alright, so after adding the 1, it's 529. Alright, and this is what? 23 squared? Yeah, this is 23 squared. Yeah, 23 times 23, yeah, 529. So n plus 1 is either positive 23 or negative 23. Right. Solving each of these, we get n equals 22 or negative 24. And again, I get 2 possible answers. Right, and both work. Both are equally valid here. One answer is, when n is 22, the next consecutive even number would be 24. And then, 22 times 24 is 528. All right. 22 times 24 is 528. And you can check that with a calculator or do it by hand if you wish. But so that pair of integers works. But also, all right, negative 24, when n is negative 24, right? Then the next one's n plus 2, negative 22. Here's consecutive even numbers that also have a product of positive 528. Right? So this is also a valid answer. And I would write both if I were you. Great. All right, next question. All right, so now we get some different instructions here. Now it still says solve using any method, but then we're asked to round our answers to the nearest tenth if needed, right? That's 1 decimal place. All right, we're moving into exercise 202. Right, the base of a triangle is 6 more than twice the height. The area of the triangle is 88 square yards. Find the base and the height of this triangle. All right, so again, I'm going to pull up a piece of paper and have the problem and the paper on the same screen. So again, I'm going to draw just a very generic triangle here. Just a general triangle. And the side that's flat, parallel to the bottom of the page here, call this the base. And then the height, once you've established the base, the height is from the opposite vertex perpendicular to the base. So you go straight down, right? And that's a 90-degree angle there. So this is the height, this dotted line here. And there's some information you're going to need to remember about triangles, right? This happens in some word problems where certain information isn't provided. It'll be assumed that you know some things. So hopefully you recall that the area of a triangle is half the length of the base times the height. Alright, so hopefully that rings a bell. Right. Now, reading through the problem again. It says the base of a triangle is 6 more than twice the height. So if I call the height, I'm going to say let the height, I'm going to call the height, h for height. Then the base is the other thing we're asked to find, right? We're asked to find the base and height of this triangle. Now you could call the base b if you wanted. But as I said, don't really need to introduce more variables if you don't have to. Because they told us the base of a triangle is 6 more than twice the height. So twice the height would be 2h, and 6 more than that would be plus 6. So they told us this in the first sentence. The base is 6 more than twice the height, 2h plus 6, if I called the height h. I hope that makes sense. So I have an established, expression for the height, h, and an established expression for the base, 2h plus 6. And now I'll just substitute this information into my area equation. Right? They told us that the area of our triangle is 88 square yards. So that's where the equation is going to come from. So the area, right, equals 88, square yards, but I'll just put 88. Well, what's area? Right, I said it already. It's half the base times the height. So 1/2 times the base, right? The base is this expression, 2h plus 6, times the height I called just h, equals, right, there's the area, equals 88 square yards. Maybe I should write square yards, like that. So that means my height has to be in yards and the base will be in yards as well when I'm done. Alright, now we can simplify this by distributing the half to this 2h plus 6. Right, half times 2h plus 6 would be, 1h plus 3. And then we have times h, equals 88. And then I'll distribute the h here. We get h squared plus 3h, equals 88. Alright, and we can do the complete the square thing again. But I see how this can be easily solved by factoring. Alright, watch this. Right, I'm going to subtract 88, and we have h squared plus 3h minus 88 equals 0. And this factors quite nicely to h plus 11 times h minus 8. Right, that would be h squared, minus 8h plus 11h for the plus 3h, and then minus 88. Okay, and then using the zero product property, the solutions here are h equals negative 11 or h equals positive 8. Now you got to remember though, we're talking about height of a triangle. So even though this is an answer to this is a solution to my equation, this doesn't make sense as a height. Right? It doesn't make sense to say the triangle has a height of negative 11 yards. Alright, these are lengths. Lengths should be non-negative. So I'm going to eliminate negative 11. Right, not because it's not a solution of the equation, but because it doesn't make sense in real life. Right, it doesn't make sense in the context of the problem. I hope that you understand that. So the only one that does make sense is this one. Right, having a height of positive 8. So now I can answer the question. Right, the height of this triangle is h, right, 8 yards, right, 8 yards. All right, they gave us area in square yards, right, so the lengths should be in yards. And then the base, remember the base is 2 times height plus 6. So that'd be 2 times 8 plus 6, 16 plus 6, 22 yards. Right. 22 yards. And then double check, would a triangle with this base and this height have an area of 88 square yards? Well, half the base is 11 times 8 would be 88. This is perfect. So this is our answer. This is what they wanted, right? The height of the triangle would be 8 yards and the base of the triangle 22 yards, right? In order for it to have an area of 88 square yards. And have the base be twice the height plus 6. Right? 6 more than twice the height as they described. Wonderful. All right. Next question. Let's look at now this is exercise 204. So another triangle problem. Right? A triangular banner for the basketball championship hangs in the gym. It has an area of 75 square feet. What is the length of the base and the height if the base is 2/3 of the height? So a pretty similar problem. Again, let me pull up a piece of paper with this so that you can still see the question, right? Exercise 204. This is example 5. So again, I'm not going to draw a triangle again because really it's just a generic triangle. But we're told, we're trying to find this base and height, right? So the base of the triangle, the height of the triangle. And since they gave us the base in terms of the height, right, they tell us that the base is 2/3 of the height. I'm going to call the height, this time I'll use x, why not? Right? Or h, or whatever you want, right? So if the height is x feet, right, because the area was given in square feet, the height of the triangle, say, is x feet, and they told us the base is 2/3 of the height. Usually the word of implies multiplication. 2/3 of the height, right? So 2/3 times x, and that would also be in feet. Right? And we're told, the information we were given is that the area of this triangle is 75 square feet. All right, and that should be enough to be able to answer their question, right? To be able to solve this problem. Remember, the area of a triangle is half the length of the base, so half of 2/3 times x, times the height, which is just x again, right? And this is equal to 75, and here's my quadratic model. Now half of 2/3 is 1/3, so this is 1/3 times x squared, right? You got times x, right? Equals 75. Here's the quadratic equation that we're trying to solve. Okay, easy enough. Multiply by 3, clear the fractions, right? We got x squared equals, that'd be 210 plus 15, 225. And 225 is nice, it's actually 15 squared. So x is either equal to positive 15 or negative 15. But again, remember what these represent. X is the height of a triangle. This again, this negative answer doesn't make sense in real life. Right? You can't talk about having a negative height. So I'm going to eliminate that option. Right? Not because it's not a solution of the equation I set up. Right? This is a solution of the equation. It just doesn't make sense as the height of a triangle. So it's this one here that makes sense, right? Positive 15. So now that I've solved the equation, I can answer their question. the base and the height. The base of the triangle, the height of the triangle. Now the height was x, right? The height was x. So x is 15, that's the height, 15 feet. And the base, remember, is 2/3 of the height. 2/3 times x. 2/3 times 15 is 10. Right, so this triangle has a base of 10 feet and a height of 15 feet. And that's my final answer. And double check, just the base is 2/3 of the height, great. And the area of a triangle with these measurements would be 5 times 15, half the base times the height. 5 times 15 is 75 square feet. So that totally works. Wonderful. All right, next question. This is exercise 206. All right, so now we're on a rectangle. All right, we had triangles the last couple problems. Now we're dealing with a rectangle. A rectangular lawn has an area of 140 square yards. Its width is 6 less than twice the length. What are the length and width of the lawn? Right, so again, keep the problem up there, and you pull out a piece of paper. This is exercise 206, example 6. All right, so this one I'll draw, some generic rectangle. So a rectangle, remember, is a 4-sided figure with, all 90-degree angles. Right. And there's a width and a length, and I'll call this side the width, and I'll call this side the length. Right. And it really doesn't matter, you can switch them. Now the area, right? Again, they don't tell us a formula for the area of a rectangle, but they're assuming you know it. Right? Remember, the area of a rectangle is its length multiplied by its width. Right? Or just base times height, if you want to call them base and height, but it's length times width, that simple. Alright, so like with all the other problems, right, I'm going to assign expressions to my unknowns. We have the length of the rectangle, we have the width of the rectangle. Now, again, you can call these L and W if you wish, but they gave us enough information to where I don't need to introduce two variables. They told us, its width is 6 less than twice the length. So if I call the length, x or L or whatever you want to call it, if I call the length x, the width is 6 less than twice the length. Well, twice the length would be 2x, and then 6 less than that would be, minus 6. Subtract 6 from that. So the length is x, yards, right? Because they gave us area in square yards, so these will be in yards. So the length of this rectangle is x yards, and the width is, twice that minus 6, right? 6 less than twice the length. 2x minus 6 yards. All right, and we're also told that the area of this rectangle is 140 square yards. All right, that should be enough to set up my quadratic equation. So remember, area here, it's the area of a rectangle. Length, x, times width, 2x minus 6. And this should be equal to, 140. And then we're solving this equation. All right, so I distribute the x. Got 2x squared minus 6x, equals 140. All right, something I'm noticing is that every single coefficient is an even number. So I'm going to divide both sides by 2 just to make the numbers a little smaller. You don't have to, but I like doing it. So now we have x squared minus 3x equals 70. And you can solve this by completing the square. You take 70 away and use the quadratic formula. Take this up here, sorry. I'm going to take away 70, and this is actually one we can solve by factoring. We have x squared minus 3x, and then minus 70 equals 0, and this factors nicely to x minus 10 times x plus 7. All right, and then using the zero product property, right, the solutions of this equation are x equals 10 or x equals negative 7. Once again, think about the problem. This is a rectangle we're talking about. X represents the length of this rectangle. So having x be negative 7, once again, doesn't make sense in real life. Right? Having a negative length. So I'm going to eliminate it. Right? Negative 7 is gone. The only one that does make sense is having a length of positive 10, right? Positive 10 yards. And then I can answer my question. Find what they want me to find. Right? They want the length and the width of this rectangle. Well, the length, remember, I called x, and we said x was 10, 10 yards. And the width, right, the width is 2 times x, so 2 times 10, 20, minus 6. It should be 14 yards. And there you go. And just make sure that these actually satisfy the conditions. If I take twice the length and then subtract 6, I get the width. Great. And the area would be length times width, 10 times 14, which is 140 square yards. That works. I checked it out. Right. Wonderful. Okay, next question. Exercise 208. All right. So this is about surface area. It says the new computer has a surface area of 168 square inches. So lengths will be in inches. If the width is 5.5 inches less than the length, what are the dimensions of the computer? I think they're talking about the computer screen. Right. Because they give us the width, and they give us width, and they want us to find the length and width. Notice there's no depth. There's no third dimension here. Even though surface area would imply that I have a three-dimensional figure and I'm finding the area on all the surfaces. So I'm going to assume here we're talking about just the computer screen. All right. And also looking back through the section, section 9.5 here, they don't talk about three-dimensional figures at all, right? So this must be just the rectangular computer screen. All right, so pulling up another piece of paper here. So I've got this, rectangular computer screen. I guess I didn't need to draw this because I'm just drawing a generic rectangle. They said that it has an area of 168 square inches. And it has a width and a length. I'll say W for width, L for length. But I don't want two variables though, right? So I'm going to let the width and length be represented by some expression. Now they told us that the width is 5.5 inches less than the length. So let's say the length is x, right? the width would just be x minus 5.5. Right? X minus 5.5, like they have. Right? Hope that makes sense. And I've got my equation up here. So I have enough information to solve, to answer their question here. So our area is length times width. So x times, and then x minus 5.5 equals 168. Alright, now 5.5 is just 11 halves, right? So this would be x squared. Distributing the x, you have x squared minus 11 divided by 2, that's 5.5. I like fractions more than decimals myself. I mean, decimals are nice too, don't get me wrong. Equals 168. Right. And then if you don't like the fraction or you don't like the decimal, if you didn't like the decimal, you could have multiplied everything by 10. If you don't like the fraction, you can just multiply everything by 2. Right. And then I'd have 2x squared minus 11x equals 320 plus 16, 336. Right. And then let's solve this thing. I'm going to subtract 336. And this time I'll try solving. I mean, it's probably factorable based on previous problems, but I'm just going to try solving this by using the quadratic formula. So x equals, the opposite of b. Remember, it's got to be in this form first. Ax squared plus bx plus c equals 0. X equals the opposite of b, so positive 11, plus or minus the square root of negative 11 squared would be positive 121, minus 4ac, but since c is negative, this will be a plus. And then 4ac, so 4 times 2 is 8, and 8 times 336, 8 times 300, 2400, plus 240, 2640, plus 48, so 2688 would be 4ac. I'm just going to double check that with off with the calculator somewhere. Alright, and then all this divided by 2 times a is 4. And we have 11 plus or minus. Now this is 2,809, which has a square root of 53 that I already checked. Right? And then all this divided by 4. So we get two possible solutions here. Right? One is x equals 11 plus 53, which is 64, divided by 4 is 16, or x equals 11 minus 53 will be negative, negative 42 divided by 4, which would be negative 21 halves, or negative 10.5. But once again, we're talking about lengths of a triangle, of a rectangle. Right? Remember, x represents length, so this doesn't make any sense because it's negative, right? We don't want negative lengths. So the only one that makes any sense at all is a length of 16 inches, right? Area was given in square inches, so the lengths and widths will be in inches. So now I can answer the question, right? Talking about this rectangular computer screen. The length of the screen is, the width would be, alright, well, the length was x is 16. The length would be 16 inches. And the width, remember the width is 5.5 inches less than the length. So 16 minus 5.5 would be 10.5, right? 10.5 inches. And let's double check, would the area be 168? 16 times 10 is 160, and then 16 times a half is 8. 168 would be the product of 16 and 10.5. Fantastic. Fantastic. So these are the correct dimensions of that computer screen. Great. Yeah, so again, I used a calculator over here. I mean, you can do it by hand, but you know, that's a pretty big number, 2,809, to know the square root of off the top of your head. All right. Wonderful. Next question. Exercise 210. Right, so now we're back to a triangle, and more specifically, a right triangle. Right, a right triangle. All right, so here the hypotenuse of a right triangle is 10 centimeters long. Remember, the hypotenuse is the longest leg, right? The longest side. That's the side of the triangle opposite the 90-degree angle. I'll draw a picture. Then one of the triangle's legs is 3 times the length of the other leg. Find the lengths of the 2 legs of the triangle, round to the nearest tenth. Okay. So again, I'll pull up a piece of paper here, and you can see number 210. So this is example 8, exercise 210. Here's a right triangle. Remember, a right triangle is a triangle that has a 90-degree angle in it, right? A little box there for 90 degrees. The side opposite the 90-degree angle, that's the longest side. That's called the hypotenuse. Right, and they told us that this side here is 10 centimeters long, right, the hypotenuse. All right, then these other 2 sides are called the legs. Right, the sides that form the 90-degree angle are called the legs. So I'll call this leg 1, and I'll call this side leg 2. All right, and what you're going to need to know about right triangles is that the Pythagorean theorem holds for right triangles only, right? You may have heard the Pythagorean theorem before. So in a right triangle, and only a right triangle, that's the symbol for triangle, you take one of the legs and square it, add the other leg squared, so leg 1 squared plus leg 2 squared is equal to the hypotenuse squared, the longest side squared. Right. So it's the sum of the squares of the legs equal the square of the hypotenuse. You may have seen this before. You may have seen it as a squared plus b squared equals c squared or something like that. All right. Now, they told us one of the triangle's legs is 3 times the length of the other one. So I'm going to say let's let leg 1 be x centimeters long, and leg 2, let's say leg 2 is 3 times that. Right? One leg is 3 times the length of the other leg, so 3 times x centimeters. So this is x centimeters, and this is 3 times x centimeters, 3 times as long. Great, now I have enough information to set up an equation, right, using the Pythagorean theorem. So, x squared plus the other leg, 3x squared, is equal to the length of the hypotenuse, which would be 10 squared, or the hypotenuse squared. Well, this is x squared plus 9x squared equals 100. So this is 10x squared on the left side equals 100. Dividing both sides by 10 gives me x squared equals 10. And so x equals positive square root of 10, or x equals negative square root of 10. But as we've seen in earlier problems, we're talking about the length of a leg of a triangle. So no negative lengths. Get rid of this negative one, this negative solution. That doesn't make sense in the context of the problem. So there, square root of 10. All right, so leg 1. So here's the answer. one of these legs, leg 1, has a length of the square root of 10 centimeters, which, they asked us to round this to the nearest tenth. So I'll pull up a calculator. All right, let's go the square root of 10, approximately 3.2, if I round to the nearest tenth. And then triple that, right, times 3 for the other leg, about 9.5. Right, 9.48 rounds to 9.5. So leg 1 is about 3.2 centimeters long, and the other leg, leg 2, is about 9.5 centimeters long. So leg 1 is about 3.2, and then the other leg would be 3 times the square root of 10 centimeters, which we saw is about 9.5 centimeters when I round to the nearest tenth. And there you go, that's what they asked us for, right? The lengths of these legs, given that one is, 3 times the other. Okay. Great. Next question. All right, so now we're on exercise 212. And they give us a little diagram here, a little picture. So it says nautical flags are used to represent letters of the alphabet. The flag for the letter O consists of a yellow right triangle, right? So this is a right triangle here, this yellow triangle, and a red right triangle, which are sewn together along their hypotenuse to form a square. The hypotenuse of the two triangles is 3 inches longer than a side of the flag. So it's already drawn for us. See, each side of the flag they're calling S inches. So this length of S inches, width of S inches, and the distance across the flag, right, the hypotenuse of the right triangle is S plus 3 inches, 3 inches longer. We're just asked to find the length of the side of the flag. What's S? All right, what's S? So I'm just going to draw this picture and solve for S. All right, so I don't need to see the problem anymore. I'll just draw that picture. Right? So this is example 9, exercise 212. So here's that, the yellow triangle. Right, they said that, and it's a right triangle. They told us that. This leg has a length of S inches. This length is the same, S inches. And the hypotenuse was 3 longer, S plus 3 inches. And since it's a right triangle, I can apply the Pythagorean theorem. Right, so by the Pythagorean theorem, S squared plus S squared, right, the length of one leg squared plus the length of the other leg squared, is equal to the hypotenuse squared, right, the quantity S plus 3. That's the hypotenuse squared, and there's our quadratic equation. And we're going to solve this for S. Alright, so the left side is 2S squared. The right side, remember what it means to square something. S plus 3 times S plus 3 again, and then FOIL. You have S squared plus 6S plus 9. Right, not just S squared plus 9. Please don't distribute powers. Right. Alright, then if I take everything to the left, we'd have S squared minus 6S minus 9 equals 0. This, you know what, I'm going to solve this by completing the square actually. Alright, so I'm going to add the 9 back. You can use the quadratic formula or try factoring, but I'm going to add the 9 back here, and then we'll complete the square. On S squared minus 6S, you'd be adding 9 to both sides. And that gives me S minus 3. That quantity squared on the left equals 18 on the right. So S minus 3 equals, positive square root of 18. which reduces to 3 times the square root of 2, right? The square root of 9 times the square root of 2. Or s minus 3 equals negative 3 times the square root of 2. And then I would add 3 to both sides to get my possible values of s. So s equals 3 plus 3 times the square root of 2, or s equals 3 minus 3 times the square root of 2. But this is a negative number, right? And this is negative here, and you can punch it in the calculator and verify that. But so I'm not going to use it because we're talking about the side length of a leg of a triangle. I don't want negative lengths, so I'm going to use this one. Right. So the length of a side of a flag, right, the length of a side is this s, right, which is 3 plus 3 times the square root of 2 inches. Now they did ask us in the exercises, the instructions before these exercises, to round this to 1 decimal place, round to the nearest tenth. So yet again, I'm going to pull up a calculator, and we'll put in 3 plus the square root of 18, right? 3 plus 3 times the square root of 2. And rounding to the nearest tenth, this would be approximately 7.2. So approximately 7.2 inches. And there you go. I'll box that in. Great. Okay. Again, that comes from the fact that you have a right triangle. You can use the Pythagorean theorem. And if this is the length of a side, it's about 7.2 inches, then the length of the hypotenuse would be about 10.2 inches, right? It should be 3 inches longer, if they asked, but they didn't. Okay, next question. Exercise 214. So here, John has a 10-foot piece of rope that he wants to use to support his 8-foot tree. How far from the base of the tree should he secure the rope? Alright, so I'll pull up a piece of paper with this. We'll draw a picture. Right. You're going to see a right triangle forming here. Now, of course, this is assuming that, well, let's just say this is the tree. Right? I'm not a very good artist. This is just tree. Right here, this vertical line. We're going to assume that the tree forms a 90-degree angle with the ground, that it actually shoots straight up out of the ground. And he's trying to support this tree with a 10-foot piece of rope. Now the tree is 8 feet tall, they said. So the tree is 8 feet high. Trying to support with a 10-foot rope. 10-foot rope. So from the top of the tree, put it on the ground somewhere, right, to support the tree, like a beam almost. And the question is, how far from the base of the tree should he secure the rope? So here's the base of the tree. How far away should he secure the rope to the ground? So I'm going to call that x. X feet. And do you see the right triangle here? All right. Got a right triangle. So x squared plus 8 squared, right, the sum of the squares of the legs, equals the hypotenuse squared, right, 10 squared. So this is x squared plus 64 equals 100. Subtracting 64, we get x squared equals 36. So x is either equal to 6 or negative 6. But again, I'm talking about lengths of a side of a triangle here, so get rid of the negative 1. Right? And there we go. Positive 6. So the way I would answer this question, right, and you should be answering most word problems with a complete sentence, right, things that make sense to the reader. John should secure the rope six feet from the base of the tree. And that's it. Right. So this is 6 feet now. Great. All right, next question. Exercise 216. All right, so this one they're giving us a little formula. All right. They're saying an arrow is shot vertically upward at a rate of 220 feet per second. Use the projectile formula. H equals negative 16t squared plus v0t, v sub 0t, and I'll write what these letters mean, right? H represents the height off the ground, t represents time, and since the projectile was shot, and this would be in seconds here because they give us speed in feet per second, and v sub 0 is initial velocity. Right. And we'll count upward as positive velocity and going downward as having a negative velocity. Right. And determine when the height of the arrow will be 400 feet. Right, so once again, I'll draw a little picture. All right, so this one doesn't involve a triangle or a rectangle. It involves a parabola. Right. So again, here's the ground. This arrow is shot up, and then eventually it reaches some peak, and then it's got to come back down, right? So let's say the arrow follows this trajectory. I'm putting little arrowheads on this, right? Now they're telling us, and they give us this little formula, the projectile formula, right? H equals negative 16 t squared plus v sub 0 times t, where again h is the height off the ground in feet, t is time, the time that the arrow has been in the air, in seconds for this particular problem, and v sub 0, well, they already told us, right? Shot vertically upward at a rate of 220 feet per second. And I'm going to count going up as having a positive velocity and going down as having a negative velocity. So shot upward, this is a positive velocity of 220 feet per second. So my formula here is now this. H equals negative 16 times t squared plus 220 times t, right? 220 is that v sub 0. Now the question becomes, it says when will the height of the arrow be at 400 feet? So the question is, when is h equal to 400 feet? So I'm just substituting 400 for h in my formula. So we have this quadratic equation, 400 equals negative 16t squared plus 220t. And one thing I'm noticing is that all these coefficients are multiples of 4. So what I'm going to do first is divide everything by 4. And then I'll put 100 on this side equals negative 4t squared plus 55. Yeah, 220 plus 55t. All right. and then I'll put everything to one side and we'll use the quadratic formula, and I'll pull a calculator up for this one. Right, we're asked to round to the nearest tenth anyway. So that'd be 4t squared minus 55t plus 100 equals 0. And then we use the quadratic formula. All right. So I'm going to take this over here. So we got t equals 55 plus or minus the square root of 55 squared. Right? Negative 55 squared would be the same as 55 squared. Minus 4 times a, 4 times 4 times 100. Then all this divided by 2 times a, 2 times 4 is 8. Now this is 3025 minus 1600. It'd be 1405. I'm just going to enter this in my calculator. Right? So pulling the calculator back up. So one of these is, quantity 55 plus the square root of 55 squared minus, and then again 4 times 4 times 100 would be 1600. I'll just put 1600. Then get out of that, and all that divided by 8. Alright, so that's approximately, so one of the solutions is t is about 11.6 seconds. That's one time when the arrow will be 400 feet in the air. And then for the calculator, if I just want to change this plus to a minus. All right, 55 plus 55 minus the square root. So then second entry, and then I scroll back through and change the plus to a minus. Great. And that's also positive. So there are two solutions here. 11.6 seconds and 2.2 seconds. So one's coming up and one's coming down. All right, let me show you. All right, so I'll circle these, right? So let's say, 400 feet in the air is like this. Say this is 400 feet in the air. Well, if it's shot from here, that means it's hitting this point at t is approximately, 2.2 seconds. That's the coming up. And then it goes up, and then it starts falling down, coming back down toward the ground. And it will again be at 400 feet coming down, and this is at t equals, approximately 11.6 seconds. Right. So that's why there are two answers here. Wonderful. Okay, I hope that makes sense, right, with the trajectory of a projectile. Two answers. Great. All right, next question. Exercise 218. All right, so this is another one where they give us an initial formula here. So a stone is dropped from a 196-foot platform. Use the formula h equals negative 16t squared plus v0 times t plus 196 to determine how many seconds it will take for the stone to hit the ground. And notice they're telling us since the stone is dropped, its initial velocity is 0 feet per second, right? Because again, they're giving us feet in seconds here, so velocity should be in feet per second. But since it's dropped, right? The initial velocity would be 0 feet per second, right? It wasn't thrown or shot or anything, just let go. All right, so once again, I'll draw a little diagram here for you. All right, so let's say here's the ground. Then there's this 196-foot platform. Oops, 196 feet. And the stone's starting up here, and it's simply dropped, right? So here's this, let's say this is the stone, and it's simply dropped. And it's going down, 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 right? That's it. Right, so here's this again, the platform, and the stone is just dropped. And they're telling us the height off the ground. Again, h represents the height off the ground in feet. It's negative 16 t squared plus v0 times t plus 196, where again h is the height off the ground in feet this time again. T is time, the time the stone has been falling in seconds. And v sub 0 is 0 feet per second, right? Because it is dropped and not thrown. All right, so back here, let's pull this up. So I put in 0 for v sub 0. We have this formula, h equals negative 16 t squared just plus 196. All right, easy enough. Okay, then the question becomes, the question is, when is h equal to 0 feet? Right, because that corresponds to hitting the ground. Right, because if you hit the ground, you're at 0 feet off the ground. I hope that makes sense. Right. So I'm just putting 0 in for h. Right, so that's 0 equals negative 16 t squared plus 196. And yet again, I notice that all the coefficients here are divisible by 4. So I'm going to divide by 4 first, just to make the numbers a little smaller. So you still have 0 on the left, equals negative 4 t squared plus, and then 49. Yeah, it'd be 160 plus 36, 196, yeah. Okay, and then you solve for t squared here. You can actually solve this one with the square root property, because there's a variable in a square and no variable outside that square. It'd be 49 fourths, right? I'd subtract 49, divide by negative 4. So t is either equal to positive 7 halves, which is 3.5, or t equals negative 3.5. But that doesn't make any sense with the problem. Having a negative time, going back in time, that makes no sense at all. So I'm eliminating that, and we're keeping this one, right? So 3.5 seconds later, t equals 3.5 seconds. It'll take 3.5 seconds, 7 halves seconds for the stone to hit the ground. Right? So that's my answer. I'm going to write in a sentence. So t equals 3.5 seconds to hit the ground, right? To hit ground. Cool. All right, again, that was pretty nice. They gave us a formula. Wonderful. All right, next question. Exercise 220. All right, so this is a uniform motion problem. It's been a while since we've seen one of these in my intermediate algebra videos, but still, you should know how to set this up. So the couple took a small airplane for a quick flight up to the wine country for a romantic dinner, and then returned home. So the same distance both ways. I hope that's clear. The plane flew a total of 5 hours. So the time there plus the time back is 5 hours. And each way the trip was 300 miles, right? 300 miles both ways. If the plane was flying at 125 miles per hour, what was the speed of the wind that affected the plane? Right. So one trip is, with the wind, and then we're assuming a lot here. Right? We're assuming that the wind is at a constant speed and you're always traveling at a constant speed, right? We're just trying to make as simple a problem as possible. We're also assuming that the wind is at the same speed in the same direction during both trips. Right? So a lot of stuff going on here, but we're going to turn this into a uniform motion problem. So question 13, exercise 220. So a uniform motion. Remember, with uniform motion, the distance traveled is equal to the speed or the rate of travel multiplied by the time of travel. Right? You might remember that distance equals rate times time, or d equals rt, right? R times t. And if you recall, I like making these tables. A distance, rate, time table for the trips involved. And we have 2 trips. Now, there's a trip to wine country. And then the trip back home. Alright, now what I'm going to do is I'm going to assume that the trip to wine country was with the wind. Let's say that the trip to wine country was with the wind, and let's say that the trip back home was against the wind. Pardon me. Just to ease our purposes, right? Just pick one. One's with the wind, one's against the wind. They want us to find, the speed of the wind. So I'm going to call the speed of the wind W for wind. Now remember, traveling with the wind, the speed of the wind makes us faster. Takes the speed of the plane and adds to it. When you're traveling against the wind, it slows you down. It takes the speed of the plane and slows it down, right? Subtracts the wind speed. Alright, now the distance traveled in both trips was 300 miles. So I'm going to put 300 in both of these. The rate of speed, now they said the plane traveled 125 miles per hour, but to wine country was with the wind, so plus W. Alright, again, I just picked one to be with the wind and one to be against the wind. It doesn't matter. And then on the way back, 125 minus W, right? Speed of the plane minus the speed of the wind. We're being slowed down. And remember, if distance is rate times time, then time is distance divided by rate. And that's what we're going to use to fill in this part of the table. The time traveled to wine country would then be 300 divided by 125 plus W. And the time traveled back home would be 300 divided by 125 minus W. Right, and we're told that the total time was 5 hours. And there's my equation. Right, I'm going to write an equation from that. Total time is just the time to go to wine country plus the time to get back home. So 300 divided by 125 plus W plus 300 divided by 125 minus W equals 5. All right. Now, something I'm noticing is that 300, 300, and 5, all have a common factor of 5. So right now I'll divide by 5 just to make the numbers a little smaller. So that'll make this 60 divided by 125 plus W plus 60 divided by 125 minus W equals 1. All right, just to make the numbers a little bit smaller. So now we have a rational equation, right? An equation with fractions. Remember how to do these, right? This has been a while since these as well. You find the LCD, right? The least common denominator, which would just be 125 plus W multiplied by 125 minus W. And then I would multiply both sides by the LCD. And the whole reason for doing that is to cancel away the denominators, right? On the left side, the first term, the 125 plus W would cancel, and I'd be left with 60 times the quantity 125 minus W plus, and then the second term, the 125 minus W's would cancel. I'd be left with 60 times the quantity 125 plus W equals, and then the other side I just have 1 times the LCD. So just the LCD, 125 minus plus W times 125 minus W. Okay. This is a quadratic equation. I'm going to solve. So I distribute the 60 here, distribute the 60 there. Okay. Now let's see. 6 times 125, that'd be 600 plus 120, so 720 plus 30, 750 with another 0. So that's 7,500 there, minus 60W plus, and then 7,500 here, 60 times 125 again, plus 60W. So that's nice, the 60Ws will go away. Then I FOIL over here. Now actually this is a product of conjugates, so you just end up with the difference of squares, right? It'd be 125 squared minus W squared, right, when you multiply conjugates. Alright, so 7,500 plus 7,500, 15,000, right? So that's 15,000 when I add those 7,500s. The 60Ws are gone. And then 125 squared is 15625. And then minus W squared. Then we solve for W squared. Right, W squared would be 625 then. And so W equals 25 or negative 25. Nice. Alright, and again, which one, you can use a calculator injunctive, all these numbers. I was just kind of saying them out loud real fast, I apologize. But now the only one that doesn't make sense here, when we're talking about speed, right? Speed should never be negative. Velocity can be negative, but speed won't be, right? So get rid of the negative 25 there. There we go. W equals 25. The speed of the wind, which was W, was 25 miles an hour. Right? So the wind, the answer, and my answer to this question, wind was going 25 miles per hour. And let's double check that. All right, let's double check that, right? So if I was, if W was 25, then the speed going to the wine country would be 150 miles an hour, so that would take 2 hours, right? And then going away, it would be 100, that would take 3 hours. 2 hours plus 3 hours is 5 hours. This works. Having the wind be 25 miles an hour works with this problem, with the conditions they gave us. Okay, so yeah, that was a lot there, but hopefully I refreshed your memory as how to work a uniform motion problem. Right? Distance equals rate times time. Because this next problem is also a uniform motion problem. All right, so next question, exercise 222. Rick paddled up the river. So upriver means against the current, and then downriver means with the current. Right? So Rick paddled up the river against the current, right? Spent the night camping, and then paddled back. Right? So went the same distance both ways. Right? Went up the river to some spot, and then went back down river, back to where he started from. He spent 10 hours paddling, and the campground was 24 miles away. If Rick kayaked at a speed of 5 miles per hour, what was the speed of the current? Right? So this is very similar to exercise 220, right? Example 13, where I'm going to have a distance, rate, and time, and we're trying to find the speed of the current here instead of the speed of the wind. Right? But it's still a very, very similar setup. Exercise 14, number 222. So again, I'm going to set up distance, rate, time table, uniform motion problem. We got, against the current, traveling against the current, and traveling with the current. All right, and I'm going to call the speed of the current that they're asking us to find. All right, they're asking us to find the speed of the water, speed of the current. I'm going to call that C for current. All right. All right, now the distance traveled both ways was 24 miles. Right, this is in miles. Right, the rate of speed will be miles per hour, and the time is in hours. I forgot to write the units up last time. I should apologize. I usually write the units above the columns. But the distance traveled both ways was 24 miles. Right, it was 24 miles there, 24 miles back. He spent 10 hours paddling. That's going to be at the end. Total of 10. The total time there plus time back will be 10. That's going to be the equation later. And the speed, right? They said he kayaks 5 miles an hour, but going against the current, that would be minus C, right? 5 miles an hour for the kayak on its own, but then I take away the speed of the current, right? I'm being slowed down. Then with the current would be 5 plus C, right? The speed of the kayak, 5 miles per hour, plus the speed of the current to speed me up. And then time is distance divided by rate, so 24 divided by 5 minus C. And here 24 divided by 5 plus C would be the time to come back with the current. Alright, and they told us that the total time traveled was 10 hours, right? He spent 10 hours paddling. So the time spent paddling against the current, 24 divided by 5 minus C, plus the time traveled paddling with the current, 24 divided by 5 plus C, should be equal to 10 hours. So there's the equation we're solving. 24 over 5 minus C plus 24 over 5 plus C equals 10. Alright, and again, something I'm noticing is that the coefficients of all these terms are a multiple of 2. So just to make the numbers a little smaller, I'm going to divide everything by 2, both sides. So that'll be 12 divided by 5 minus C plus 12 divided by 5 plus C equals 5, right? Just to make the numbers a tad smaller. The least common denominator is 5 minus C times 5 plus C. And I'm going to be multiplying every single term by the LCD. Okay. First term, the 5 minus C's would cancel. I'd be having 12 times the quantity 5 plus C, plus the second term, the 5 plus C's would cancel, and I have 12 times the quantity 5 minus C. And then the other side we have 5 times the LCD. Now 5 minus c times 5 plus c would be 25 minus c squared. Right? Multiplying conjugates gives me a difference of squares, 5 squared minus c squared. All right, then I have, this is a quadratic equation, right, that I need to solve. So distribute 12 here, distribute 12 there. We got 60 here, 60 there, so that's 120. And then 12c minus 12c, so just 120 on the left. All right, very nice. The 12c's would cancel. And then here, distributing the 5, got 125, right, 5 times 25, minus 5c squared. And if I solve for c squared here, we're just going to get 1. Now I would subtract 125, divide by negative 5. C squared equals 1, meaning that c equals 1 or c equals negative 1. But, we're talking about speed of the current in miles per hour. Having a negative speed doesn't make any sense. Again, you can have negative velocity, just not negative speed. So there it is there, right? C equals 1. So the current was going 1 mile per hour is our answer. Right, put that in a box. So that's our final result, final answer. And if you want to see if it makes sense with the problem, put in 1 for C. So going against the current, he would have been kayaking 5 minus 1, 4 miles per hour for a total of 6 hours then. 24 miles divided by 4 is 6. 6 hours there. And then 24 divided by 6, 5 plus 1 would be 4 hours. 6 hours and 4 hours makes the total of 10 hours that they said he was paddling for. So that works. Great. All right, next exercise, 224. Just got 2 more here. All right, so this is about doing work problems. You again have seen this. It's been a while, but you've seen this before. So 2 gardeners can do the weekly yard maintenance in 8 minutes if they work together. The older gardener takes 12 minutes more than the younger gardener to finish the job by himself. How long does it take for each gardener to do the weekly yard maintenance individually? All right. So again, we got a work equals rate times time problem. All right. Let me pull up this. All right. So remember, work done equals the rate at which you work multiplied by the time that you work for. All right. Now you have the older gardener, you have the younger gardener, and then them working together. Now, they said together they can do, remember rate is going to be the work done by divided by time if that's the case. Right? If work is rate times time, the rate at which you work is the work done divided by the time. Their together rate, so I'll just say rates for all these, right? This is the rate at which these people work. They said they can do 1 yard or one week's yard maintenance. 1 week's yard maintenance in 8 minutes. So that means they do 1/8 of the weekly maintenance per minute. Right. Now the younger gardener, we don't know how long it takes him, right? So let's let T be the time it takes the younger gardener I'll let T be the time it takes the younger gardener to do weekly maintenance, all the weekly lawn maintenance, And this will be in minutes. Right. So if it takes this guy, the younger gardener, T minutes to do it, then the rate at which the younger gardener works is 1 over T. They do 1/10 weekly maintenance per minute. Hope that makes sense. And if T is the time it takes the younger gardener to do weekly maintenance, the older gardener does it in T plus 12 minutes, right? Because it says that the older gardener takes 12 more minutes than the younger gardener to finish the job by himself. So the rate at which the older gardener works is, they do 1 weekly yard maintenance divided by, over the T plus 12 minutes it would take them to do it. And then the key, right? The key here to setting up an equation is that the sum of individual rates of work is going to be equal to the rate at which those individuals work together. And that is the key to setting up any equation involving work and work rates. So this means that the older gardener's work rate, 1 over T plus 12, plus the younger gardener's work rate, 1 over T, is equal to the rate at which they work together, which would be 1 over 8. Right? They do 1/8 of the job in a minute together. All right, and then we're solving this rational equation. All right, so the LCD, right, you gotta find the LCD and multiply both sides by the LCD. All right, the LCD here would be 8 times T plus 12, and this is going to be multiplied by every single term. All right, so the first term here, the T plus 12 would cancel, you'd be left with 8T, plus this with T would cancel, you'd have 8 times T plus 12, 8 times the quantity T plus 12, equals, and over here just the 8 would cancel, you'd have T times T plus 12. All right, and this is a quadratic equation that I'm solving. Distribute the 8, distribute the T, we'd have 16T, 8T plus 8T plus, and then 8 times 12 is 96, right? So 16T plus 96 on the left equals T squared plus 12T on the right. Now let's take everything to one side. 0 equals T squared, and then minus 4T, right, when I subtract 16T, and then minus 96. Right, and this actually factors nicely. This is T minus 12 times T plus 8. So the possible solutions here are T equals 12 or T equals negative 8, but you got to remember what T represents. T represents what they asked us for, right? They asked us for how long does it take these gardeners to do the time, to do this work by themselves, right? T is the time it takes the younger gardener to do weekly maintenance. So we don't need negative time, right? This doesn't make any sense. So T is 12. Now that's not the final answer, right? The way I would finally answer this question is the following. The younger gardener takes 12 minutes to complete the job. That's what T represented, right? T represented the time the younger gardener. And then they said that the older gardener takes 12 more minutes, so just t plus 12, as I wrote up here earlier, right? T plus 12 for the time it takes the older gardener to complete the job. So the older gardener would take 24 minutes to complete the job by himself, right? Or by herself, or their self. Okay. And that's it. Wonderful. All right. Fantastic. Okay, then I have one more question. All right. Number 226. So Sully is having a party and wants to fill his swimming pool. If he only uses his hose, it takes 2 hours more than if he uses his neighbor's hose. If he uses both hoses together, the pool fills in 4 hours. How long does it take for each hose to fill the pool, individually? All right, so this is the same kind of problem as number 15. It's a work problem. All right, so let me again pull this up here. So I read through it. Now again, you got his hose, the neighbor's hose, and then if you use them together, we're talking rates, right? These are rates of work. Now, I read through the problem. What do they want? They want to know how long does it take for each hose to fill the pool. So I'm going to let the time it takes his hose to fill the pool, or Sully's hose to fill the pool, be something, and the time it takes the neighbor's hose to fill the pool be something else, right? Another expression to fill a pool. Now they told us that if he uses his hose, it takes 2 hours more than if he only used the neighbor's hose, right? So if you use the neighbor's hose by itself, let's call that T. So say it takes T hours to fill the pool with the neighbor's hose. Then it would take T plus 2 hours to fill the pool with his hose, right? Because it takes 2 hours more. I hope that makes sense. So the rate at which these hoses fill the pool, his neighbor's hose fills the pool, one pool every T hours. So one pool per T hours, 1 over T. That's the rate of work for the neighbor's hose. The rate of work of his hose is, it fills one pool every T plus 2 hours. Right? So 1 over T plus 2 pools per hour. And then the hoses together fill it in 4 hours. So that means they fill 1/4 of a pool per hour. Right? This is pools per hour. All these rates here. Okay. And again, the key is that the sum of the individuals' rates of work is equal to the rate of that they would work together. All right, and that's where the equation is going to come from. So 1 over T plus 2 plus 1 over T equals 1/4. All right, now the LCD is 4 times T plus 2 here. And this is going to be multiplying every single term. First term, you just have 4T plus second term, the T's would cancel. You have 4 times the quantity T plus 2. And then equals on the other side, the 4's would cancel. You just have T times T plus 2. Right, we're solving this quadratic equation for T and then answering our questions. All right, so I distribute the 4, distribute the T. You have 4T plus 4T is 8T plus 4 times 2 is 8. 8T plus 8 on the left equals T squared plus 2T on the right. And taking everything to one side, 0 equals t squared minus 6t minus 8. This does not factor nicely. So I'm actually going to do this by completing the square. This would be t squared minus 6t equals 8, right? Adding 8 to the other side. All right, and then we'll add 9 to both sides to complete the square. I hope you remember how to complete the square. This would be t minus 3 squared equals 17. So then t minus 3 equals, square root of 17, or t minus 3 equals negative square root of 17. So t equals, 3 plus the square root of 17, or t equals 3, minus the square root of 17. But this is negative, and we don't want negative time, right? So I'm going to eliminate that and keep this. And now I answer the question. Right? And they asked us to round these things to 1 decimal place to the nearest tenth as well. But they're asking for how long does it take for each hose to fill the pool, right? So the answer to the question, Sully's hose takes t plus 2, so 5 plus the square root of 17 hours. And the neighbor's hose, remember neighbor's hose I called t hours. Sully's was t plus 2. The neighbor's hose takes 3 plus the square root of 17 hours to fill the pool. And if we want to round these, let's round these, right? Pull up a calculator. So 3 plus the square root of 17. So about 7.1 hours. A little more than 7 hours to fill the pool. And if it takes the neighbor's hose about 7.1 hours, then it takes his hose about 9.1 hours. I just add 2. And that's what they want, right? They want us to round all answers to the nearest tenth if necessary. Okay, and then let me just go back through and double check my work. Right, you should always be double checking your work. Yeah, 2 hours more. Rates, add the rates equals blah. 4t, 4 times t plus 2, t times t plus 2. And 8t plus 8. T squared plus 2t. Yeah, this is exactly right. Okay, so yeah, that was a lot, almost 2 hours here. But, the same principles every time, right? Any word problem comes up, any application problem, you read through it, make sure you understand what they're asking you for, and then usually you assign some expressions, like t and t plus 2 or whatever, assign expressions to those unknowns, what they're asking you for. And then you read back through the problem and try to find any sentences that can be translated into an equation, or find bits and pieces of information that can be translated to an equation. Now if there's not, that means there's probably some information they're assuming you know, right? Like that the area of a triangle is half the base times the height, or the area of a rectangle is length times width, or that distance equals rate times time, or the sum of the individual rates of work equals the together rate of work. There are some problems where there is some assumed knowledge. But I think if you've seen enough and practiced enough, that knowledge should be ingrained in your brain. All right, so I'm hoping that watching me go through these 16 questions here help you in some way when you're asked to solve applications that end up using a quadratic model on your own. And thank you very much for watching.